Unit 5, Day 3, we do inverse of exponential and log functions, which the inverse of an exponential function is a log function, and a log function would be an exponential function. Just like we did in Unit 1 when we had quadratic, if like we did a quadratic function, it would inverse to a square root function. Similar thing happens here with exponential to log and log to exponential. So anyways, first one, f of x equals 8 to the x power. This one is in exponential form, so I know it's going to go to log form. I'm still going to do FSIR, which we learned with inverse back in Unit 1. F standing for, I'm changing my f of x to y. S standing for switching my x and my y. I standing for isolating y. To get rid of an 8, which is the base, I can't just subtract 8 or divide by 8 or something like that. I have to convert to log. Now I don't have any extra numbers. I just have a base, exponent, and a number on the other side. So to convert to log, I just write log. I put the base. I put the exponent, which is y. Remember, a log statement always equals the exponent, so y is going over here. X goes here. And I was trying to isolate y, and guess what? We did that by converting. Last step, turn y back, return y to f of x as an inverse. Hopefully you'll notice that if I take those, the one we just did and the inverse we just got, they are inverses. They're reflecting across the y equals x line. They have coordinates that they share, like 8, 1 here turns into 1, 8 right there, as well as others. In my second one, we're going to do a log function's inverse, which will inverse to exponential. Still FSIR. I'm going to go ahead and change my f of x to a y. I'm going to go ahead and switch my x and my y. I don't have any extra numbers, so I'm going to go ahead and convert. How do I know I don't have any extra numbers? That's my base. That's my exponent. That's my number on the other side. There's nothing extra. So let's convert to exponential. The base is 4. The exponent is x. The number on the other side is y. And look, once again, y is by itself. This is the inverse. We'll return y back to f of x as an inverse. And my second one is done. So if I ask you right now what the base is, what would be the base? Definitely a 4. What would be the exponent right now? According to the rule, a log statement is always equal to the exponent, so the exponent is x. The number on the other side is the y, so the reason I went ahead and labeled it, do we have any extra numbers? Yep. Which one do I get rid of first, the times 3 or the plus 2? Yep, so I'm just going to subtract 2 to get rid of 2, right? How am I going to get rid of times 3, by the way? Yep. When I divide by 3, which one divides by 3, the x or the minus 2? Both of them. So again, what happened? I got rid of plus 2 by subtracting 2. And then after that, I got rid of times 3 by divide by 3. I had to divide everything that was over here. The minus 2 was already over here. So let me ask you those questions again. Which one is the base now? Yep, still 4. And no, it doesn't look like it or sound like it. Which one is the exponent? Yep, this part right here is the exponent. And that's the end, so there's no extra numbers at this point. So now I can do what we came here to do, which was to get y by itself. How do I get rid of log 4? Convert it. Convert it to what form? It's currently in log. Thank you. We're converting to exponential. So just ask yourself BEN again. What's the base? 4. What's the exponent? X minus 2 over 3. I know it looks awkward. What's the number on the other side? Y. Once again, we got y by itself. Change y back to f of x, and you got it. If you ever think it looks kind of weird and you don't trust it, put the original in Desmos and put your inverse in Desmos and see if they look like inverses. See if the coordinates are flipping. Which leaves us with just one more. Last one is a good one to finish. I'm going to go ahead and convert f of x to y. I got a 2 to the x over 3 power and a minus 5. Step 2, go ahead and switch. So I had already did the f step. Now I'm going to switch them. So it's 2 to the y over 3 power and minus 5. So something not necessarily unique, but there is a very important point I need to make out. And that point is what's extra right now and what's extra later. So we clearly see, I think we can tell that there's two extra numbers, minus 5 and divide by 3. But one of them is extra right now. And by right now, I mean that one of them is not part of BEN. We've got a base, we've got an exponent, we've got a number on the other side. What's extra right now? Right. I don't got to get rid of 3 till later, as you'll see, because 3 is part of the exponent. It's not really extra. So we all know how to get rid of minus 5. I'm going to go ahead and add 5. So again, all I have is a base, an exponent, and a number on the other side. So I am free to convert. Convert to what form? Yep, I'm currently in exponential. I'm going to convert to log. Once you write the log word down, the rest kind of, it seems like it gets going. Always ask yourself BEN. Which one is the base again? 2 is the base, right? Base of the exponent. What's the exponent? Y over 3, right? Does it go on the left side or the right side? Exponent goes over here by itself, right? A log statement always equals the exponent. And then x plus 5 goes here. So I said there's an important point that's getting made. Have I got y by itself at this point? For the first time, y is not by itself yet, is it? So 3 is an extra number now, but it wasn't originally an extra number. It was part of the exponent. But we all know how to get rid of a divide by 3. Yep, so it's going to be 3 times log base 2 and x plus 5. And at that point, we are done because y is by itself. Other than the fact I need to change y back to f of x. So the key there, some numbers are extra in the beginning, and sometimes you have a number that's just extra in the end. What's the difference? 3 being our extra number, it was part of the exponent, so it wasn't necessarily extra. But in the last one we did, 2 wasn't part of BEN, 3 wasn't part of BEN. We got rid of those up front. We only had a base. The exponent was over there. Once we did our little changes, we had our N right there. So as far as, again, there's no delta on this. There's a list of 9 problems, but you only got to choose to do 3 of them. Since I'm only giving you 3, the method behind the madness is I'm looking for 3 that are very well worked out. I'll post the answers, but I'm not posting the steps. If anybody needs me to work out some in a small group, matter of fact, probably what I'll do is in a few moments I'll wait and see if anybody needs me to maybe work out one like number 6 or one like number 9. They're just like the ones that y'all did. So when you do any 3, you're choosing one from the first set, one from the middle set, and one from the bottom set. So you're getting one. The first set doesn't have any extra numbers. The second set either has 1 or 2 extra numbers, and the third set also either has 1 or 2 extra numbers.